Hello everybody. So we're going to continue with chapter 10, lesson 2, classify triangles by angles. Alright, so basically how can you classify triangles? By the size of their angles. So this lesson all we're doing is looking at the size of the angles in the triangles. There is another way to name triangles by their size as well, but right now we're just focusing on the angles. Alright, and so on the read the math here, when you see the triangle and then the letters A, B, C, we would say triangle A, B, C. So in this shape, there's actually many possible names for the triangle. I could say A, B, C, where B is in the middle. I could name it B, C, A. I could name it C, A, B. So basically, we're just naming it by its three different angles. Okay. So any combination of the three letters, angle ACB, BAC, CBA. Okay, and now an angle of a triangle can be a right, an acute, or obtuse angle. It cannot be more than one of those at the same time. So all triangles either are called a right triangle, an acute triangle, or an obtuse triangle. And basically, the way we name those is because one of the angles in a right triangle would be a right angle. In an acute triangle, all three angles are less than a right angle. In an obtuse triangle, one of the three angles in the triangle is greater than 90, which means the other two are less than 90, or less than a right angle. So if you can get three different color pencils, a red, blue, and orange, we're going to identify these triangles based on the size or measurement of their angles. And I'm going to start with the right triangles first, because one, they give us a clue. It has the blue square. So I'm going to color in all the right triangles red. All right. Now you can move to angles that have at least one obtuse angle. And you can use the tool here. So if I was to line up this angle here with the vertex, you'll see that I can't see the other ray. So that's an acute angle. If I go this way, I can see this lines up with this edge, but I can't see this angle. So that's an acute angle. If I go to the top one, I can see this edge where my corners lined up, but I can't see this angle. So all three of these are acute angles. Now when I look at this one, and I put the corner of my angle or my paper with that ray, okay, I'm lining up this ray here. You notice that this is a lot wider than the corner of my paper. So this one is an obtuse angle. So I'm going to color that blue. Okay. And then this one also looks like an obtuse angle. Let's verify that. I'm going to put my paper, line up the corner there. And so a right angle would be this way. And this part of the ray angle is wider than the corner of my paper. So this is an obtuse angle. Okay, then I think this one right here is also an obtuse triangle. So I'm thinking this angle here is obtuse. So let's put the corner of my paper there. Okay, so I'm lining up with this ray here, and this ray is definitely off of the paper, off the edge of the paper, so that is an obtuse angle. Okay, and then we already said that this was an acute angle, but acute triangle. All three of its angles were less than a right angle. And this one here is going to be acute as well. Okay, so that's what those should look like. Now, page 403 at the bottom, to try this section. Oh, let's go ahead and look at the math practice question here. Can a triangle have more than one obtuse angle? No, it's not possible. If you had two angles greater than a right angle, you wouldn't be able to close the triangle with only three angles. Okay, so like on this one here, if I had another angle like that, so it would come up here like this, and then this one would come out like that. So we'd have three angles, but it wouldn't be closed. It would no longer be a triangle. So a triangle with an obtuse angle must have two acute angles with it. All right, name the triangle with one right angle. Well, that's pretty easy, isn't it? It's that one right there, right? So I can name that, remember, use the triangle symbol, and I'm going to call it QPR. QPR. It could also be called RPQ. Okay. It could be called RQP, QRP, so on. Okay, multiple ways. Name the triangle with one obtuse angle. You start to look at these and you start to recognize that, oh, all these angles are acute angles. They're less than right angles. So this one right here must be an acute angle. And you can verify that. Use the corner of your paper, line it up with one of the rays of the angle, and this is open much wider than the side of the paper. So triangle with at least one, with one obtuse angle, X, Y, Z. And name the triangle with three acute angles. That's this one right here. Triangle A, B, C. All right, 404. Page 404. So here's the definitions of these. An acute triangle is a triangle with three acute angles. Okay. Three acute angles. An obtuse triangle is a triangle with one obtuse angle. And a right triangle is one with a right angle. So we need to know those three definitions. Use a Venn diagram to classify the triangles. Write the names of the triangles in the Venn diagram. So typically we'll see a Venn diagram with the circles overlapping in the middle. But these will not overlap because you cannot be an acute triangle and a right triangle at the same time. You cannot be an obtuse triangle and an acute triangle at the same time. You can't be an obtuse triangle and a right triangle. Okay, so these are all three different ways. You can't be the same. There's only three names for for triangles, and you can only have one of those names at a time. All right, so RST. All of those angles are acute. So triangle RST that's one possible name for it. Okay, this one is a right triangle, and the symbol there gives that away. So we're going to call that triangle PQR. This is also a right triangle. So triangle BCD. Okay, so we've named that one, and that one. Now, triangle VWX looks like an obtuse triangle, and it is. So here's the corner of my paper. If it was a right triangle, it would have the edge going here, but the rest of the angle is opening out off the edge of my paper, so that's an obtuse triangle. So we're going to name triangle WVX is obtuse. I was going to even write their names in here. All right, what would be your guess on this one? I think it is more than likely an acute triangle. Let's verify. So if we line up the edge of the vertex of the corner of my paper with this angle, you notice that we do not see this ray. So this angle is acute. If I line up N, the vertex of N, angle N, I can see the edge that I've lined up with, but I don't see this ray. So that's an acute angle. And M, okay, if I line up the side of my paper with this ray, I don't see the other ray here. So this is an acute triangle. So triangle, I don't know, LMN. This triangle looks like this one. Triangle ABC. And then we have two triangles left. Well, I think, looking at this, that DFH is an obtuse angle. So when I line up one edge of my tool with the vertex of this, so when I line it up with ray FD, you notice that ray ray FE is open a lot wider than what would be a right angle. So this is obtuse. So triangle DFH. And we have one triangle left. And when I look at this, I think this is an obtuse angle. So when I line up the corner of my paper with angle I, you notice that ray IG is not lining up with the edge of this on this side of the corner of my paper. So it's a wider than a right angle. So this is an obtuse triangle. So triangle GHI. Oh, on this triangle, I named the H here for some reason. It's actually DFE. Okay. H is part of this triangle. All right. So let's see what we learned here. Name the triangle. Tell whether each angle is acute, right, or obtuse. A name for the triangle is F, G, H. F, G, H. That's one possible name. Angle F. Angle F. Okay, so if angle F was a right angle, angle F would come out here. It's not. It's less than a right angle. So this is acute. Angle F is acute. Angle G. Angle G has the blue square symbol. We know that means it's a right angle. If we wanted to just confirm it, we would notice that it lines up perfectly with the corner of my paper. Okay. And angle H. Okay, so angle H. So if I line up this side of it, if it was a right angle, it would come out to here. So angle H would go like this, but it's not. It's coming in. So this is also an acute angle. Okay. So number 2, classify each triangle. Right acute, right, or obtuse. Again, these triangles have to have one of these 3 names. It can't be more than one of them. All right. I'm thinking when I look at this angle up here, that's an obtuse angle. Let's verify it. All right. So if it was a right angle, it would come down here, but it's open a lot wider, so this is an obtuse triangle. This is definitely an acute angle. That's acute. But I'm not sure about this one. I think that's an obtuse angle. Let's check it out. All right, so the edge of my right angle would come right there, right? See how it makes a square corner? But this one doesn't, because it's a lot wider. So this is also an obtuse triangle. Okay, when I look at this one, it just looks like all the angles are less than 90. So I'm looking here. That's less than a right corner, right? That's less than a right angle. And that's less than a right angle. This is acute. All right, let's continue. Again, we're just going to name these 3 triangles based on the measurement of their angles. This one gives it away. It's a right triangle. This shape, this triangle, we look at all the angles. Those are all open less than a right angle. So those are acute angles. So it's an acute triangle. Okay, this one gives it away. It's a right triangle. Number 8, cross out the figure that does not belong and explain. All right. Well, I believe this one is an obtuse triangle. Yes. Okay. So right angle would be like that. And so this is open wider. So this is obtuse. This one, that's an angle. That angle is acute. That angle is acute. And that angle is acute. So that's an acute triangle. This looks like an obtuse angle. Yes. This part right here is open much wider than what a right angle would be. So this is obtuse. And well, if I'm looking for something that doesn't belong and 2 of them are obtuse, I'm going to assume that this one's obtuse, but let's verify it. So I line up the corner. A right angle would go this way, and this is open wider than the right triangle, by a right angle, so it's obtuse. So which one does not belong? That one does not belong. The crossed out figure is an acute triangle. The other three are obtuse triangles. The other three are obtuse triangles. All right, number 9. Use the Venn diagram for 9 through 10. Okay. Which triangles do not have an obtuse angle? And explain. Well, triangles D, E, F, and triangle SPN cannot have right triangles. And that is because acute triangles must have 3 acute angles. Triangle ABC and triangle GHP because a right triangle cannot have an obtuse angle and a right angle. Okay, so these two cannot have obtuse angles. Remember, the triangles only can have one name. It's either an acute triangle, a right triangle, or an obtuse triangle. So if we're looking for triangles that do not have an obtuse triangle, it's got to be these two. Okay, because you can't have two names for the same triangle. So we can't call this a right obtuse triangle. It's just a right triangle. I can't call this an acute obtuse triangle. It's just an acute triangle. All right, so how many triangles have at least 2 acute angles? How many triangles have at least 2 acute angles? Don't all triangles? But we're looking here, right? So if one of the angles is obtuse, the other 2 must be acute. A right triangle, the other 2 have to be acute. In acute triangles, all 3 have to be acute. So 7. An obtuse triangle must have 2 acute triangles. An acute triangle must have 3 acute angles. Oh, must have 2 acute angles, not triangles. Must have 2 acute angles. One acute triangle must have 3 acute angles. And a right triangle must have 2 acute angles. All right, number 11. Use the square shown at the right. Draw a line segment from point M to point P. Okay. So get your straight edge, and we're going to draw a line segment from point M to point P. Okay. Name and classify the triangles formed by the line segment. Okay, so triangle MNP. Triangle MNP. That looks like it forms a right corner, right angle. Yep. So this is a right angle. This is a right angle. So we made two right triangles. So triangle MNP and triangle MQP are right triangles. Why? Because they each have a right angle and two acute angles. All right. Number 12. Write the letter of the triangle under its correct classification. All right, so I see two that are the easiest ones to identify. So we have triangles C and E are right triangles. Triangle A is an acute triangle for sure. F looks clearly like an obtuse triangle. Line up the corner with the vertex, and the right angle would go there. So this is open. This angle is open much wider. So triangle F is obtuse. Looks like D is also obtuse. Line up the corner of the paper. If it was a right angle, it'd be going straight up here. It's not, it goes way out. So triangle D is an obtuse triangle. And that leaves us B. And so B looks like an acute triangle. I put the corner there. So this one is less than 90. This is less than a 90. Less than a right angle. Sorry, we haven't been talking about degrees yet. And that would be a right angle. So this angle here is less. So these are all acute angles. Okay. So AB is an acute triangle. D and F are obtuse triangles. And C and E are right triangles. So that's it for lesson 10.2. In our next lesson, we'll talk about how to classify triangles by their sides. So until then, may the numbers always be in your favor.